Mr. Brown, and you're watching What's the Matter? This video represents the introductory video to the channel. So I'd like to start it by first saying thank you very much for taking the time out of your day or night to learn something new with yours truly. In these What's the Matter videos, we will discuss, you guessed it, matter and everything that it involves. But our goal throughout this series will be to not only enjoy the science of chemistry, but to simply get it. So grab your pen and a pad, pull out your keyboard, put yourself in that good positive vibe, and let's do this. When we talk about the world of chemistry, we're taking part in the study of two major concepts: matter and energy. If one is to understand chemistry, they must learn all about what matter is, how it undergoes changes, and the energy that is associated with it all. Matter is literally everything around you. Anything in the world that takes up space and has a mass is defined as matter. This means that everything that you see at this very moment with your eyes is considered matter. From the floor below your feet, to the screen in front of your eyes, to the paint on the walls to the side of you, to the air that's inside of you. All of it is considered matter. And throughout this series, we're going to learn just how special that matter is. Since the beginning of time, people have always tried to not only understand the matter that's around them, but manipulate it to their benefit. Now think back at our human ancestors and try to feel the level of astonishment that must have came upon them when they first made a fire. In order to do this though, they needed to not only learn about how wood was, but they needed to understand how to harness enough energy to make that wood burn. I'm sure way back then they figured this out through trial and error, but as science has evolved, so has the process that scientists follow to just figure stuff out. This process that a scientist will follow when they're trying to figure stuff out, solve a problem, or answer a question, is called the scientific method. Now the scientific method is just simply a procedure, a generic procedure, that ensures that the information obtained from any type of inquiry is accurate and reliable. According to the scientific method, first you have unanswered questions, then you have educated guesses, and you have experiments and tests to determine what would actually happen. Next, the experiments and tests are changed if necessary, but most importantly, they're repeated. And finally, a conclusion is made based on the results that were obtained. As scientists use the scientific method to answer questions and solve problems that we have in our world, they are able to develop theories and laws. And these guide our understanding on what different matter is and how different matter will behave. This world is just filled up with matter interacting with other matter. From talking to someone, to buying something that was manufactured in a company, to texting your friend or scrolling through social media. All of it is matter connecting with other matter. Now with all of this matter out there in the world, and all that could go wrong with it and does go wrong with it, wouldn't it be great if there was a single source that we could go to that contained all of the important information? Well, yes, of course, there is. This source that contains all of the important information about a material is called a safety data sheet, SDS. The safety data sheets were developed to identify the substance, provide information on any hazards that material may pose, ensure the substance is used correctly, and most importantly, highlight the appropriate responses in any various situation that may occur with that material. All SDSs are developed in the same format and in a way to simply explain the physical and chemical properties of a substance. These sheets are major in the scientific community and in a scientific laboratory, not only because they save lives, but because they contain critical information regarding materials. Where do you think we get all this critical information about a material? In order to understand what matter is and how matter behaves, we must measure it. But what exactly are measurements? If I told you I was going to give you 5, what would you say? I'm pretty sure you'd ask me 5 what? And that's because 5 by itself has no meaning. I'll give you 5 slaps, or I could have wanted to give you $5 million. Either way, Without the unit attached to that number, it has no meaning. Of chemistry, you will learn very quickly that the unit attached to the number is just as important as many of the units you use in your everyday life. So what are some things that we measure in our everyday life? We have time, and when we measure time, we add a unit such as minutes to give it its meaning. We have mass, and when we measure mass, we add a unit such as grams to give it its meaning. We have volume, and we assign a unit such as milliliters. Temperature, we use Celsius and Fahrenheit. And we even measure energy, which has units such as watts or joules. A unit of measure will provide a scientist with a reproducible way to assign value to measurements of mass, length, volume, energy, etc. Throughout history, scientists have developed and utilized various systems to make meaningful measurements. And throughout chemistry and throughout this channel, we will discuss the SI system, which is the International System of Measure. Throughout the What's the Matter series, we will learn how units in the SI system are used to measure matter and how these same units can be manipulated and changed to help us better understand the matter that we are studying. We have a basic understanding of what matter is and how measurements are used with it. Let's try a quick exercise to test your measuring skills. At the prompt, pause the video and measure the length and width of your screen using only your finger. Write your measurements down and calculate the area of your screen using the formula area equals length times width. But don't forget to write your answer down. No matter what you wrote down, if you did not include the unit, your measurement had no meaning. And if this was a chemistry test, that answer would be wrong. For this calculation, you would have wanted to use the unit fingers squared to give your number and your measurement the meaning that it deserved. The area of my computer screen with the length of approximately 4 fingers and a width of approximately 6 fingers would be 24 fingers squared. In chemistry, the units really mean everything. And as chemist in training, I want you to get used to writing down a unit every single time you take a measurement or you write down a number. But if units give our measurements and our numbers and our values meaning, what gives them dependability? Thinking back to the scientific method, after an experiment is completed and results are obtained, the test is repeated. This is done so that you can ensure that the measurements obtained are both accurate and precise. If you went out to a field and shot a bow and arrow, do you want to shoot all over the place or do you want to hit that bullseye every single time? Well, that is what it is to be accurate and precise. Well, when we're talking about accuracy and precision, we have different levels of it. Now, let's say you were out there shooting a bow and arrow and not having the best of days, and you were hitting the target in generally the same area, but not hitting the bullseye, then at this scenario, you would be precise, but not accurate. Let's say you're hitting close to the bullseye, but you're not hitting in the generally same area every time, then you would be accurate, but not precise. And of course, if you were out there hitting all over the place, not hitting anywhere as close to the bullseye and anywhere as close to the same spot, then you would be neither accurate or precise. And if you were in there, John Wicking it, hitting that target every single time, dead bullseye, then you would be both accurate and precise. And as scientists in the lab, getting measurements, that is what you're trying to be. Being that most of the scientific data about matter is and has been obtained through measurements, it is imperative that a scientist is accurate, precise, and those measurements are reproducible. I hope you've all enjoyed the video, and I hope they're going to get better over time. But most importantly, I hope you all learned something new. In the next video, we will discuss how to be grade A precise when making a measurement, how to determine the important significant numbers in a measurement, and how to determine the level of uncertainty that we will have when we take a measurement. Thanks for watching What's the Matter? I'm your guide, Mr. Brown, and I hope you all have a wonderful day.